Hi, my name is Savannah, and this is my lab report from the first lab regarding charge tapes. The purpose of this lab was to determine the excess charge on a strip of clear tape and examine interactions the tape had with other objects to determine whether or not the tape was positively or negatively charged. This required me to carefully perform the experiment, work through calculations to determine the excess charge, and create a computational model of the scenario. The key physics concepts in this lab include the idea of retraction and repulsion and the calculation of electric force. The equations on the right demonstrate how the equation for an electric force and electric field can be combined to create a usable equation for the variables that can be determined in this experiment. Additionally, knowledge of gravitational force, force equals mass times gravity, was essential in solving for the charge on the tape. As a preview of the results, the calculated excess charge on the strip of tape was 2.69 times 10 to the negative 8 coulombs. The ratio of electrons to atoms was calculated to be 4.24 times 10 to the negative 7. The two strips of tape had identical positive charges, as they were repelled from each other but attracted to a negatively charged pen. This experiment had three main steps: testing room conditions and tape to ensure that the tape would be positively charged and attracted to other objects, interacting with the pen to determine if the tapes were positively or negatively charged, and the floating tape experiment to calculate the electric charge on the tape. The numerical results needed to calculate the electric charge are the width, length, mass, and the distance the tape was raised. These numbers are featured on the left. The figure on the right demonstrates how the experiment was performed, and the distance between A and B was the distance used to calculate the electric charge on the strip of tape. These were the calculations needed to determine the electric charge on the tape, which was 2.69 times 10 to the negative 8th coulombs. The number of atoms was 3.962 times 10 to the 17th atoms. The number of electrons, which was 1.68 times 10 to the 11th electrons, and the ratio of atoms to electrons, which was 4.24 times 10 to the negative 7. On the right side, you can see that the gravitational force was set equal to the electric force. Rearranging the variables within this equation led to an equation where the measured values could be plugged into the equation. The other calculations involve finding the area of the tape and of an atom to calculate the number of atoms, the charge of one electron to the total charge of the tape to find the number of electrons, and then dividing these two numbers to find the ratio from electrons to atoms. This figure is the result from my computational model. The purple arrow represents the electric force, while the red arrow represents the gravitational force. The blue spheres represent the depiction of the two tapes as 2-point charges. This is the code that I wrote for my computational model. In order to perform these calculations, I needed to assume that the charge on tape A and tape B were the same. An atom's shape can be approximated as a square. Each tape could be treated as a point charge, and air resistance on a moving object could be ignored. Potential sources of error in this lab included human error, which would have occurred without carefully handling of the tape. If my hand accidentally touched a piece of the charge tape, some of the charge may have been redistributed, making the results inaccurate. Additionally, sources of error could have come from the environment. Since the experiment was performed during an intense lightning storm, electricity in the air could have affected the results that were found in the lab. These questions prompted some thinking at the end of the lab. If electrons had positive charges and protons had negative charges, the experiment would likely stay the same, and the interactions with the charged tape and other objects would also remain the same. This is because the tapes would still match each other's sign and charge, while the pen would have an opposite charge to the tape, allowing the tape and the pen to be attracted. It is important to handle the charged tapes as little as possible, as the charge can be discharged to other objects. I saw this in my experiment when I first tried to attach the upper tape to two metal soup cans. The metal discharged the charge that was stored on the tape, which prevented it from moving. When switching to plastic cups for the floating tapes experiment, there is less discharge, allowing for the experiment to run smoothly. Thank you.